Hello, everyone. Good afternoon and good evening, based on where you are. Welcome to our second session on Introduction to Internet of Things. And today I will be hosting you and will give you some overview on many different concepts related to IoT. And hopefully, we should be done in 30 to 40 minutes, depending on how many questions we have. Uh, Similar to yesterday, feel free to ask your questions on Discord. So we have a channel called Live Lecture Questions. I will pick up the questions from there. But also, if you would like, you can have your questions on YouTube. But remember that the comments on the YouTube will be public. Without further ado, let's start. So, Internet of Things. And when we talk about Internet of Things, the first thing that comes into our mind is Internet, followed by the things, of course. But then we are already aware that internet is all around our life, everyday life, whether it comes to business, comes to education, comes to social life, family life, and so on. So this very recent, I would say, data shows the percentage or the proportion of the population around the globe that are actively using internet, that are actively using cell phones or the social media. So the numbers are staggering and clearly shows that internet is our essential part of our everyday life. So we cannot move on without internet anymore. And with the growth of internet, there are many businesses that have been developed. There are new companies that are arising or introducing themselves every week or every month. There are new products that are designed and developed solely based on internet or for internet, or that runs those services or products runs through internet. There are many large uh, partners like Facebook, Amazon, Microsoft, Google, and whatnot. But then there is also other emerging Internet of Things-based companies that are designing new products, new services to protect you, to offer you new services, to save your time, to make us more smart. Uh, I would not name those companies, but there are tons of companies now that are developing IoT-based products or products that are related to IoT. And not only companies that are developing themselves or providing services based on internet, but also our everyday services like healthcare, transportation, businesses, uh, our cities, they are all basically getting smart and smarter. And all these services, like healthcare services or transportation services, they are mostly now data driven and data centric. So they not only rely on data uh, to ensure a better service, but they also produce a huge amount of data that can be used further to optimize those services. I will come with, I will show you some of the examples later on, but these data intensive services are basically becoming a de facto for our life, for our cities. And given that we are talking about Internet of Things, we are talking about various use cases of internet. So the basic question that comes into our mind: what is Internet of Things, or what do we mean by Internet of Things? So Internet of Things, as I said, the first thing that comes to our mind is Internet and the things. So it's a connected network of things that can not only sense data, that can also talk to each other or transmit those data over the internet to other devices. And in some cases, they can even process those data within their internal uh, platforms or devices, or within their internal systems. So they don't need to always transport data uh, to let us know or to make some decisions. Sometimes they can take their own decisions. So those things, basically, they are referred to as various sensors. They can be actuators, they can be many other different types of things, including your smart car, including your smartphone, and whatnot. So there is no single widely accepted definition of Internet of Things. People define it in many ways, but the standard concept is that it should be connected to internet, and it should be able to transmit data or sense its environment and then transmit those data to the internet, to somewhere else, so that the data is useful. In this picture, I'm showing one of the very simple examples of an Internet of Things device or IoT device, as most of you will be likely working with PICOM devices based on low-pi, 5-pi, or any other ESP32 devices. The device here I'm showing is connected to a DHT11 sensor, so that can basically sense the temperature and the humidity. It is also connected to a distance sensor based on ultrasound. So when we are talking about these individual sensors, they are not useful until and unless they are connected to a platform or device. In this case, the low-pi 4 or this PICOM expansion board. But then, in combination of this PICOM device and the sensors, we can call it an IoT device. But you can also think of this package. When we deploy this package, let's say, to another place or for another service, combined to the whole device itself. So let's say we put this device inside our car or inside our bird house or nest house. So this whole thing becomes a smart device. So smart device is not only about sensors, it's a combination of technologies. It is a combination of hardware and softwares and so on. So this is basically a very simple example of an IoT device, but it can be, of course, much more complex. And then this is also a typical example. There are many use cases, of course, but this is a typical example of a smart city. And as you can see, we have many different use cases in a smart city. So we have parking assistance. We have, let's say, smart lighting that turns on and off depending on the presence of a pedestrian. We have automatic watering, so it can turn on and off the watering system based on the moisture in the soil. We have smart waste containers that can trigger collection notification for the city corporation people to collect the garbage and make them empty. There can be a video camera that is making the surveillance of the area and sending the pictures or video to over the cloud to a third party or governmental agencies. There can be a flow management system based on predicting or sensing the number of cars in the street. So based on this flow management, basically you manage or handle your traffic signals. So there are many use cases, as you can see, and it is not limited to these examples that I'm showing here. So talking about the smart city, and as we know that usually cities are large, even some towns, they can be large enough. Uh, Small scale solutions might be useful or feasible for our home, let's say, when where we need or where we don't need long range network connectivity, or when where we don't need to send data uh, over more than 10-20 meters. But in the large city, or in a metropolitan city, let's say, if we have smart solutions deployed here and there, and they are sending data to the servers, let's say, over the internet, uh, we might need to consider different types of connectivity options depending on what types of solution we are deploying. Let's say we have 10 big parks in a city, in a large city, public parks, and those public parks has grasses or green beds that need to be watered during summer regularly. So based on the sensors that can be deployed in those parks, uh, they can read the moisture data and send it to the cloud, or there can be actuators that sends or triggers the action of doing the watering uh, without sending the data to the cloud. So if you are thinking this kind of use cases where you are having 10 different parks in many different locations, or in a large city, and you need to send the data, let's say, to a centralized server, sometimes you might need to cover 10 kilometers, 15 kilometers, even 50 kilometers, depending on how large the metropolitan is. So the reason I'm giving this example, because there are some network connectivity options that can give you long range coverage, like LoRaWAN or LoRa, that is long range connectivity. But there can be also some shorter range network options like Zigbee or Bluetooth that does not allow you to send data over the long range. Of course, different technologies also have different power requirements or energy requirements. So you have to be careful which connectivity options you are picking for your use case, not to spend much money on the power or the energy. On top of that, there is also installation cost. So, for example, 2G, 3G, 4G, or mobile connections, if you want to establish the connectivity, you need to set up the tower, you need to make sure that all the infrastructure is there. But if you want to set up a Bluetooth or Zigbee connectivity, or even a Wi-Fi connectivity, you don't need that much expenses. So there are different connectivity options, and there are different parameters, like what type of, how frequent you want to send the data, how large amount of data you want to send, where do we want to send the data, how the devices that you are using, how much power they consume, and so on. So there are many different parameters that you need to consider before deciding which type of connectivity you want to use for your IoT solutions. And talking about the connectivity options, as I mentioned previously, that sometimes you might need to send a large amount of data or frequently to the server. And if you want to send large amount of data, or if you want to send data frequently, obviously you will take more power, or your device will consume more power. But then also it depends whether you want to send your data to the server that is located 1 kilometer or 5 kilometer or 10 meters away. So depending on different parameters, we can basically group or cluster these connectivity options. So as you can see, if you want to send data to closer stations or very close to your devices, you can use Bluetooth or Zigbee or even RFID. That's the most classical example of sending data over the wireless connections. But then if you want to cover more range and you want to send more data, maybe 3G, LTE, or 5G connected connections are suitable. But in that case, you are also consuming more power. But we are talking here IoT devices or IoT solutions. And usually when we are thinking about IoT solutions, like sensing data from the environments and sending them to the server, we usually don't sense or don't read the data that frequently, maybe 30 minutes each 30 minutes or each 1 hour. And then we have to, or we might need to send this data to a server that is 5 kilometers or 10 kilometers away. So in that case, this kind of networks like LoRa, Sigfox, or even narrowband IoT, they are more reliable and useful. But then there is also two different types of network connections. So some are licensed and some other are unlicensed or non-licensed. So for unlicensed connectivity, you don't need to pay. So LoRa is free. So you can use as long as you want and pay nothing. But then if you want to use narrowband IoT or LTE, they might also provide long range connectivity and also wide access, but they are not free. So you have to also think about your cost. Okay, so there is a question about frequency and connectivity. So usually, if you have a higher frequency, you are having lower data rate and vice versa. So basically, with the higher frequency, you can send very small amount of data. And if you want to send more data, it should be lower frequency. And it's the same, basically. If I go back to this table, as you can see, Bluetooth and Wi-Fi, they have very high frequency, but then their data rate is not very high, very low, basically, 250 kilobyte per second maximum. But then if we are talking about 2G or 3G or 5G, those works in the cellular bands are very low frequency, but then they can have very high data rate. So they can transmit data, let's say 50 Mbps or even more speed, or more amount of data in short amount of time. So we are talking about LoRa, that is long range connectivity. And very recently, not very recently, it's started basically for a while, there is a LoRa network provider called Helium. We also had a guest lecture from Helium last year. Probably we can make that available also this year, that lecture. And that's also on our YouTube, so you can watch it anytime. So this Helium provides you LoRa connectivity worldwide, mostly, I would say, with more than 250,000 of hotspots. So basically what it does, that you can get a Helium hotspot, set it up for yourself or by yourself, and then the users will use that hotspot, and they are using basically not for free, But the more the data is transmitted through your hotspots, the more cryptocurrency you are earning. So it's like a cryptocurrency based network. Basically, you are getting intensive incentive based on your data traffic. And as far as I remember, for 24 bytes of data, you are paying only 0.00001 cents. It's like less than 50 cents for 1 megabyte of data. So that's really cheap. And for IoT applications, if you are sending data, let's say every half an hour or every hour or even every 6 hour, and if you are sending only 1 byte or 2 byte, you are basically paying nothing. And for that purpose, Helium is a great uh, connectivity options. I think most of the area in Sweden are covered by Helium, and as you can see in the map, most of the Europe and USA, even China, India, and South America, uh, Australia. So basically, Helium is available more or less all over the world, and it's increasing. The number of hotspots is increasing every day quickly. So there were a couple of more questions. Do you know if Bluetooth uses power generally to be connected or during transmission? It's only, I guess, during transmission, but even it's using the power during transmission, it's basically use too much power. For your homes applications or IoT solutions, Bluetooth might be a good solution if you are using external power. But of course, the range and the energy is a issue if you want to develop a wide area solution, or if you want to have uh, energy solutions that is sustainable. And also, yes, you can host a Helium endpoint and earn money. So basically, you will be earning cryptocurrency, not cash. Sebastian said, any specific connectivity option works better underwater? For example, a outdoor pool for measuring underwater and send data. Recently, I think there was an experiment by our team that did some experiments with LoRa underground, but not underwater. Probably it will also work for you, Sebastian, because our underground experiment did work. But be careful if you want to deploy your solution underwater, not to break your device and not to leak your device, else you are screwed, basically. And then, okay, I will come back to you, Hamlet, maybe in a later time, because you also asked about a thesis, and you said did not find any statistical difference in power consumption. That might be true if you are sending data or not, but then I don't know how large the data set is or how much data was sent in that experiment. So there are many parameters, as I said. Yes, that 50 cents is in dollars. I think it's precisely 0.44 cents per megabyte in Helium. And talking about connectivity options, we have many different use cases, as you know, for IoT. So in this table, we have like different connectivity options and how much they're applicable to different use cases. So as you can see, LP1 or LoRa, in other words, they are mostly applicable for large scale use cases like smart building, smart city, smart metering, industrial IoT, smart agriculture, so where you have to cover a wider area. But then if you move on to Bluetooth or Zigbee, they are mostly applicable to smart home, wearable devices, connected health, and small retail, and so on. But there are another difference between this type of connectivity options. For example, this LoRa or mobile network, they are mostly connected through a star topology. So basically, you have a centralized server where different devices or different sensors are sending their data. But Zigbee, Bluetooth, or Wi-Fi, they support also mesh networks. So you can create multiple devices that all are connected to each other. So this is, I think, more fancy and more feasible, and also more useful. Different areas of IoT, IoT technologies. So IoT is not only a tool or concept for implementing simple ideas or pilot cases. There are, in fact, very practical use of IoT technologies in many other areas. So be it consumer, be it commercial, be it industrial IoT, which is also a very large application of IoT these days. So, for example, in Tesla manufacturing workshops, there are no manual involvement. Everything is done by smart machines or robots. So those are basically very good examples of industrial IoT. And then there is, of course, military and infrastructure use case. So, for example, all the smart battlefield weapons, uh, they are controlled and monitored by internet using sensors. So that's also a very practical application, also maybe not so great, of IoT in the case of military. These days, IoT sensors are also used for monitoring the ocean. So the rise of the seawater, the temperature, and so on, because uh, ocean monitoring is a large application or use case, and probably these are not under consumer application of IoT, rather than they are done at the national level by the governments and through the military services. And I think there was a comment uh, to the question to Alia, that there are many factors to how much you will earn. For example, how many hotspots that exist in your area, and so on. Yes, that's right, Diaz. It depends on many factors, of course. It's not like that you will get rich overnight. So it will take some time, and also it depends how competitive your hotspots are, and so on. But the good thing is that you are providing connectivity for others, and in this way, connectivity is getting cheaper, and that is good for IoT solutions. So we were talking about connectivities. We also talked about a little bit IoT, but then let's take a look at basic IoT architecture. So what are the various layers in our IoT solution? In its simplistic term, we have 3 layers. So basically, on the top layer, we have applications. It can be enterprise applications, user applications, mobile applications, and whatnot. It can be a website. And then at the bottom layer, we have the sensors or sensing devices that send and receive data. But in between them, we also have middleware or a hub or collector that basically take the data from the sensors, little bit process the data or prepare the data and send the data or forward the data to the applications. So this is the simplistic form, but there is also a more complex view of the IoT architecture. So previously we saw only number 1, number 2, and number 6 from this detailed view of the IoT architecture. But there are also other layers within those 3 layers. So for example, we have network connectivity layer. This is nothing but provides you the connectivity. So without this layer, your IoT solutions is also dead. So you must have this layer. Then there is also data abstraction layer. Um, Basically, you want to provide correct data. You want to provide security to your data. So you might want to encrypt your data before you want to send it to the cloud, or before you send it to the storage. But then there is also cloud data servers, like where you store your data permanently. And from those data servers, basically, our applications are reading or updating based on the use case. And then there is, of course, optimization level. So based on the what we see in our applications or user applications, we might take some decisions, and we might want to optimize our or change our solution of even. So there are basically these 7 layers in any architecture, in any IoT architecture, and some of the layers are optional, some of the layers are mandatory in any IoT solution. But now I will go through some of the layers a little bit detailed. In particular, we will talk about the thing layer or device layer. We will also talk about the edge layer and the data processing layer, and the application layer. So in the things layer, basically we have sensors, we have hardwares, and then we also have gateways and some management or control services. In the data management and intelligence layer, we have data processing, data cleaning, data encryption, and some intelligence services like finding patterns, using machine learning to predict data, and so on. But then we have this application layer where we can build different types of application. And in the age of cloud, we can basically use this cloud platforms to build our services or applications. So that those can be websites, those can be industry-specific solutions, even those can be mobile applications, and so on. So now going through each of the layers, in the device layer, of course, we have sensors and devices, in other words, and there are tons of vendors who are providing or developing sensors and hardwares that we need for developing an IoT solution. And we more or less know about them already. But then talking about the sensors, there are also hundreds of different types of sensors to measure and sense the environment. But sensors can be also mainly 2 different types of sensors. So one is the smart sensors, and another one is the simple sensors. So simple sensors are basically plug and play sensors that you connect, it sends the data and send it to the server or to the gateway. So it has no computational capability. But smart sensors, they have computational capabilities. They have special microprocessors inside those sensors, so they can take some intelligent decisions, and they can do some data processing, and so on. So there can be many functionalities depending on what you want, what you deploy in that smart sensors. But for smart sensors, it's not only plug and play. You need to onboard the sensors, you need to do the configuration, and then they will be prepared for sending or receiving the data or events. I think yes, there was a feedback from Frederick to Oscar, and thanks Frederick for helping me out from somewhere else. Then we have this gateway layer or edge layer. Basically, this gateway or edges are getting data from the sensors, so multiple sensors, and then do some pre-processing on the data that are being received, like aggregating the data, summarizing the data, cleaning the data, and so on. But it also has many other responsibilities, like a gateway can work as a router, so it can route data to specific server. It can notify the server if some sensor is not reacting or not sending the data, or the sensor is not working. It can also work as a registry. So under each gateway there can be 50 hundreds, no matter how many sensors you want to connect, it can be connected. It can also provide the connectivity between the sensors or among the sensors and so on. It can also perform some transformation of the data from digital to analog, or even from string to integer and so on. So there can be many different functionalities possible by a gateway. Above the gateway, we have this data management and intelligence layer. As I said, basically, this layer is capable of doing intelligent stuff on the data. For example, applying rules on the data streams. It can look for patterns in the data. It can do some predictive analytics on the data on the fly, and so on. For example, it can also batch process the data. So not only each data comes in and it's analyzed or processed, it can process the data in a batch and also in a real-time fashion. So this layer is also critical for any IoT architecture. This layer might be embedded, but at the small scale within the sensors, that becomes basically a smart sensor. But then the power requirement for that sensor might be high. So we should be also careful of not overloading a sensor in terms of processing and sensing at the same time. On top of data management and intelligence layer, we have this application platform as a service, or APaaS. Basically, here we are building applications using the concepts of cloud computing. Basically, you have the complete IDE or framework to build, design, deploy, and integrate your application. It provides basically all different types of services, including the database and the connectivity and so on that you need. And then you can deploy your IoT solution and the application itself in one trigger or in one click. So there is very minimal development or design activity if you are using application platform as a service capabilities available in the cloud. And these are the applications, as I mentioned earlier. You can develop different types of application, whether it's mobile application or websites or any other industry specific application, like it can be an ATM booth with mounted with sensors. So it's basically finance specific application of IoT. but there can be many other industry-specific applications. But what do we mean, or what IoT applications does? So what it does is basically it analyzes and present, of course, the sensor data via dashboards. For your projects or course projects, many of you, or probably all of you, will be creating some sort of dashboards for data visualization or making some decisions. In the more advanced level, you are not only will be creating the dashboards, you might also use some machine learnings to analyze your data or predict some events. These IoT applications also help you to visualize or make aware yourself key performance indicators, because for example, in the industrial IoT, you need to be do or aware of continuous performance of your robots or devices, because if something fails, your whole production line will collapse. So you might need to be aware of these performance indicators. Let's say how many cars we are building each hour or each day. And if there is a deviation or significant deviation from that performance indicators, there might be some issues with the sensors or hardwares that we are using in the industrial IoT. So these key performance indicators are also critical and good use of IoT application that supports us. And then, of course, sending alerts to users, let's say to your phone or to Discord or any other platform. And sometimes it can trigger this IoT application automatic fixes, like if there is an actuator, it can trigger some actions to correct or solve a problem that has been identified. There are many technologies that was made possible by IoT, and also those technologies are basically helping IoT. So it's more complementary relationship. Of course, different connectivity, different sensors, advanced sensors that are available now, smart sensors. There is also cloud computing platforms. So this software as a service, platform as a service, infrastructure as a service, all these cloud computing concepts, they are very useful for IoT. And also IoT use them. Of course, machine learning and artificial intelligence and analytics that IoT use, and that is also useful for IoT. And last but not least, this conversational AI. So, in any let's say devices that act based on your voice, it can be Alexa, Google Home, and whatnot, and then they can control your smart appliances. This is also part of IoT. So these technologies are complementary to each other and made the IoT possible. There was a question about what kind of dashboards we are going to create. Yes, you already gave the answers to your questions by yourself. Thank you. Yes, you can use Grafana, Node-RED, and many other platforms there are. Our TAs will help you to decide which one you would like to experiment, which one you would like to use. But there are many more, like PyBytes from PyCom also. They have this dashboard that you can use and create. And of course, TIG stack, and there are many other stack. We will be, I think Pietro will be talking with some of the technological solutions that you can use for your dashboards and for your platform. So we were talking about IoT applications, and these all IoT applications, these IoT applications are basically all about data. And when we are talking about the data, there are tons of smart wearable devices for us. We as an individual are generating data every day, be it through mobile phone, be it through our smartwatches, and any other smart gadgets that we are using. On the right side of the slide, as you can see, there was a survey in the USA. It was back in 2013 or maybe a little bit later. So the participants were asked if they want to choose a smart gadget by one of their brands that they trust, which one they would pick. And most of the participants answered that they would pick a wristwatch or a smart device that is clipped on their clothing, or smart device that is clipped on their shoe. But there are of course other solutions like smart glasses or smart armbands and so on. So what, regardless of whatever smart wearable devices we are using, they always generate large amount of data. That of course has privacy concern because they are sensitive data, they are confidential data. So it's up to us if we want to share those data in the cloud and transfer those data to these third-party service providers, or even uh, developers or creators of these devices or of these services. But the message here is that we should not blindly share our data or private data or health data to third-party services, and we know what can be the consequences. There are many risks, of course, for IoT-based solutions. Hacking is a very common risk for any internet-connected solutions or device. Then, of course, intrusion on privacy, especially if you are using smart devices that carry or sense your personal data. Then there is also distributed denial of service attack. So your server or your IoT device might be overloaded by external requests that you, or data that you don't want to, or you don't expect basically. But there might be many other risks in IoT. So how an IoT device can be exploited? It can be exploited in many other ways. For example, of course, the typical distributed denial of service attack. It can be exploited through botnets or malware-based attacks. It can be um, exploited through some script, like let's say if your device is not meant to be developed for internet world, that means your security settings are not strong, and if someone hack it and deploy some scripts, it can change your security settings, it can change your firewall settings, and so on. Of course, the data breaches while you are transmitting your data, let's say any other technologies like Bluetooth, hackers can easily intercept your data. And the final and most obvious way to exploit an IoT device is inadvertent breaches, meaning that you unwillingly or unknowingly kept your device unsecured, meaning that your password is very weak, your data is not encrypted, so you are sending personal data without any encryption and so on. So, but there can be many other ways to exploit the data, to exploit an IoT device, that you need to be careful. Uh, okay, so there was some questions. I think can the IoT devices become botnets? Yes, if you can program in that way, but I guess nobody wants their IoT devices a killer. Uh, what else? I don't see any more questions, but there was a suggestion. Maybe we should keep Canvas or no. Okay, I didn't understand the question by Hamlet or suggestions. Okay, so we are getting closer to the end. Uh, so now talking about risk and talking about wearable smart devices, smartwatch is one of the uh, classical example how your private data is transferred and shared with third parties, and how you should not to uh, connect your device like smartwatch to other devices like your phone. So usually what we do, we turn on the Bluetooth of the phone and turn on the Bluetooth on the watch, and we just connect and transmit the data. But for hackers, it's very easy to intercept. That's why when you are transmitting your private data, you should be considering other methods of security like pins or paraphrase, passphrase, and so on. In this way, your private data will not be under risk. Uh, Yeah, good question. How do you detect a virus in an IoT device such as IoT thermometer? Uh, it might not be possible from the device itself, but from the uh, gateways or device management layer, where uh, basically you are controlling external access or unauthorized access to your IoT devices. And if your IoT device is connected to a Wi-Fi, let's say, and your Wi-Fi is compromised, definitely your IoT device is also at risk. So controlling the first access layer is basically crucial here, so that the hackers don't get direct access to your IoT device through your other connecting or controlling devices like your laptop or from your phone and so on. But yes, that's for sure that you cannot uh, get a virus or direct access to your very simple IoT device like a thermometer or thermistor that is measuring the temperature and humidity, let's say. I think I'm done with my slides. There will be a mandatory quiz published right after this session. So that is a basic IoT quiz. Although the deadline is Friday, June the 10th, but this is a soft deadline, so you can take this quiz anytime. But make sure that you do the quiz, and the better the earlier, because there will be more quizzes coming in, there will be more workshops coming in, so you might be busy with other things. But as we said yesterday, doing all the quizzes is mandatory, and of course, getting at least 60% in the quizzes. You can try those quizzes as many times as you want. There is no limitations how many times you want to do the quiz, but I believe the highest score will be counted. And there is no grading on the quiz. It's just pass and fail. So uh, if you do it more times, multiple times, you might get things right. You might know new things. But if you just do it once and get the passing score, that's also fine. Uh, yes, Matas Pipiras, the quiz will be available right after this session. So, and it will be available throughout the course. So it's not that the quiz will be closed on Friday. It will be open today, but it will be open until the end of the course, the last week of the course. So do it by this week. Better if you cannot do it by this week, do later. But you have to finish the course quiz. And yes, we will publish most of our lecture slides, at least the lecture slides by the teachers like me, Anna, Pietro, Frederick, and Marco. So we will publish all the slides on our Canvas course page. And on top of that, you have the videos on YouTube, so you can watch them anytime. And with that, if you do not have any questions, I can close the session. And thanks for joining, everyone. And we will look